So, Neil, welcome to the show. I really appreciate you coming on to help us continue to unpack this topic that is science versus pseudoscience, whether or not it's, the ways in which we might want to distinguish between these two, and whether even if it's a useful distinction to make in the first place. Obviously, Dean has gotten us off onto this path of inquiry, and you're going to be he's passed the torch on to you, and we're going to talk about some of the extra topics and sort of burrow into some specific examples that we didn't cover in the first round. So maybe to begin, you should just introduce yourself, some of your research interests, and then we'll just see where the conversation takes us.
Great, thanks. And thank you so much for having me on the show, Glen. My name is Neil Manson. I'm a professor of philosophy at the University of Mississippi. I've been here since 2003. It's hard to believe I've been here that long. My primary emphasis is at the intersection of what's called metaphysics, which I imagine a lot of your audience isn't, they may have heard of that with regards to healing crystals in New Age bookstores or something, but metaphysics, philosophy of science, and philosophy of religion. In particular, I did my dissertation on this thing, the fine-tuning argument, which is the argument that the parameters in physics that govern the whole universe are adjusted. They are just so right for the existence of life that it is powerful evidence that the universe was created by an intelligent being, probably God. And it's a long story about how I fell into writing about that topic, but that is the topic I ended up writing about. And I'll actually mention that example in some detail during this interview, I think. I also do some work in environmental philosophy, specifically on the precautionary principle, which is a decision-making principle, and I'll talk about that as well. But maybe surprisingly to the audience, but in the work I've done, I've actually had to think a good bit about the nature of science itself, and so I'm happy to be able to talk more about this question of distinguishing science from non-science, science from pseudoscience.
Yeah, actually, and just as a quick precursor, obviously the statisticians and data scientists who are listening in, they are the ones who have self-selected into the philosophical discussions around this.
Yeah, so they might know more than I think. Okay, so that's great.
Or at least they're keener than you might suspect.
Keener than I might think. That's true.
Which is, all we can hope from people, including ourselves. So, I was really interested. I view myself as someone who's, read around on these topics, and actually what got me started on the interest in whether there's a useful distinction between science and pseudoscience was I was reading some of Samir Akash's work on the philosophy of biology,
right,
as one does. And it got me thinking about the issue of on creationism versus creation science, and essentially whether it was useful to distinguish between the two methods, essentially that one is one that fundamentally rejects science as essentially a mode of truth, that essentially they have some other, they have a book that tells them where their truth comes from, versus, I guess, creation science, which is actually saying, the methods of science are valid in some way, and they happen to actually validate what is in the Bible, for example. And I was basically trying to think to myself, to me, that does seem like a distinct difference in argument. And the reasons of interest to me is obviously because the methods that you use to come to truth are about as useful as whether or not you actually arrive at the correct answer. And one we have more control over, I think. And so I then went to some biologists and said, here are my thoughts. And is this a useful distinction? And I was actually surprised. Very few of them said, they come to the same wrong conclusion, therefore it's not useful. The vast majority are yes, there are interesting aspects of this, and it does bring up some interesting, methodological questions.
Right.
And so I was surprised that.
Yeah, I'll actually talk about that too, because in the course of looking at this one kind of what's called a design argument from cosmology, along the way, I've sort of looked at other design arguments. There are a lot of them, and in particular, I actually ended up going to a long workshop on this thing called intelligent design theory, which I think is the modern version of what you were just calling creation science, and kind of seeing from the inside how they looked at it, as sort of gawker, a voyeur, I guess, as to what was going on. But yeah, it's interesting philosophically to see how they set it up, how they go about it. Yeah.
Yeah, and also I think that though you also mentioned some other cool applications or I guess topics within that I hadn't even heard of before. There's the healing crystal one. I think you talked about like Gaia theory.
Yeah, I'll get through all that stuff. I kind of have a agenda, to get to all that stuff. But before it, I want to kind of pick up where Deanne left off talking about Thomas Kuhn, because I think he really set the table wonderfully for me to say a few words about that. I was just wondering if it's okay if I...
Yeah, let's go.
It's an exposition for a while, but certainly you can jump in along the way if you have any questions. But yeah, so if you've already watched Deanne's interview, he talked about the long history of the attempt to distinguish science from non-science, science from pseudoscience. In the philosophy literature, this is called the demarcation problem. And they started off thinking that verification was the central method of science, accumulating evidence for a position. If it can't be verified, it's not really scientific, not meaningful. That was the view of the logical positivists. You had Karl Popper saying that no falsification is the central method of science. It's the ability of hypotheses to be ruled out by empirical evidence. That's what's distinctive about science. But nothing ever gets conclusively verified, was his view. Both of those viewpoints really ran afoul of some pretty simple cases. Think of something like, for every metal, there is an acid that dissolves it. Okay, that sure sounds like a scientific hypothesis. It sounds like a hypothesis about the natural world, right? But it's got two-way quantification. So if you examine a large number of metals and for all of them, there's a matching acid that dissolves it, that still doesn't conclusively verify the hypothesis, because there might be metals you haven't tested. And then if you pick a metal that you haven't found a solvent for, that also doesn't falsify the hypothesis, because it could be you just haven't found the right solvent, right? But that's clearly a scientific claim, but it doesn't meet the criteria for being a scientific claim. And it's cases like that that caused a pretty big shift in how people were looking at the demarcation problem in the 1950s. And then Kuhn came along, and I'm just going to say a few things about Kuhn. But before I get to Kuhn, I also want to mention, despite, people don't generally listen to philosophers of science, right? So they might say that there isn't a great criterion distinguishing science from non-science or from pseudoscience. But if the public believes there is, or wants there to be, and if politicians especially believe there is, then that's going to persist. There's a great book I wanted to just mention here, or a fascinating book called How the Cold War Transformed Philosophy of Science to the Icy Slopes of Logic. And it's kind of interesting. I didn't know until I read it. The US government was funding so much science research in the Cold War that philosophers of science were getting on the gravy train. And in fact, a lot of key papers in philosophy in the 50s were sponsored by Defense Department grants, right? So it just kind of goes to show that it doesn't really matter if the philosophers think some of these ideas are shaky.
Actually, this podcast is on the 1950s Defense Department grant. I'm not sure if you knew this. That's why we're interviewing all these philosophers of science.
You're kidding me.
Yeah, I'm just kidding.
Okay, well, that's good. That was a good joke. You got me. But so Kuhn, Kuhn came along in that environment. And I imagine a lot of the readers have the basic idea here, right? For Kuhn, it's not that there is an objective truth to which scientists are getting closer and closer, right? Rather, there are different communities of scientists working in different worldviews or paradigms, okay? And they stick with the paradigm until they encounter an anomaly or anomalies, which, if they don't get resolved, leads to a crisis and possibly the abandonment of the old paradigm And through what's called a paradigm shift, that was Kuhn, right? You get an entirely new way of looking at things, a new theory. But for Kuhn, it wasn't that the new paradigms were closer to the truth, right? It's just more of a random walk almost through the space of possible theories on Kuhn's view. And you can definitely say that some theories get left behind, but it's not the case that on Kuhn's way of looking at things that you're getting closer to the truth. The other really notable thing about Kuhn that subsequent philosophers of science and sociologists of science picked up on, if you are familiar with that general picture from Kuhn about how science actually works, you'll see that it comes across as a very social phenomena, a very political phenomenon. And I'm saying that now to set up where some of the things I want to talk about in this interview about how that view of science has been exploited by some people I think would qualify as science deniers. Just one more thing about Kuhn. The philosophers, I would say, did not, in general, at the time, think that this was the very best view of science. They weren't overwhelmed with it. The reception was rather critical. But as Deanne noted in the prior interview, it was probably the most cited philosophy book in the 20th century. I mean, there is one that was cited more, I would be surprised. And that's because outside of philosophy, and in particular in the humanities and social sciences, it was regarded as revolutionary, in part because it fulfilled a function. And I'm going to talk about that function in a little bit. But yeah, you said you wanted to know more about, we had a little break there, but more about incentives in science. Can you clarify what you mean by that?
You had said that in the broken section that part of the, I guess, the social function, the social issue here was that effectively the scientific paradigm did have a set of incentives that were different from just, I guess, I'll put words in your mouth, but they're different from just, purely scientific inquiry incentives that essentially that there are. Yeah.
I mean, absolutely. I mean, just think about really basic stuff. How can you do any science unless you have some money, right, for equipment and for to have a lab? Generally, you have to be part of a team, right? It's not like Dr. Frankenstein today, that image, that there hardly are any lone scientists. So you have to be
that was the real horror story of that show. That was the real horror story of that episode. It's like, create a horrible monster that murdered his family, but he was also a lone scientist. He didn't collaborate. And that's real problematic.
That's right. That's where he went wrong.
Yeah, he didn't submit his creation to peer review, which actually, I guess peer review papers are sort of like that because they basically just start inserting arms and legs into your thing.
Yeah, so, CRISPR, on the other hand, that's totally great because a lot of people are involved in that, and that can't possibly be misused, right? But yeah, the incentive system. So, I was going to tell a little story about somebody I've been reading about a lot lately, Albert A. Michelson from the Michelson-Morley experiment. I imagine your audience, a lot of them know about that. That's the experiment that determined there is no ether, right? This is the ether drift experiment. Are you familiar with that one, Glenn?
I am, simply because I was doing research for the show. I would not assume that the average person was.
So the belief of many physicists at the turn of between the 19th and 20th century, at the end of the 19th century, was that since light showed all these wave-like properties, that there must be a medium of transmission, that the light was propagated along some medium. And they call that medium the luminiferous ether, and it's suffused all of space, and that's where light waves travel. And Michelson, who developed this technique called interferometry, very, very clever experiment, was basically able to determine that the speed of light was constant, regardless of the direction in which it was propagated or the speed. So if you view the Earth as going in an orbit, there should have been a difference in the travel time for a wave of light being emitted perpendicular to that direction versus in that direction, right? And he observed no such, the experiment showed there was no such difference, okay? So this created a crisis at the time. What explains the negative result of the ether experiment, the ether drift experiment of Michelson and his colleague Albert Morley? And Einstein, the theory of relativity solved all those problems. But in the meantime, in that gap, right, from when Einstein took over, or that viewpoint took over, there were still a lot of people whose their whole way of looking at things, their whole research program, their way of life was built on the luminiferous ether as existing, and so there was resistance. It's so funny. There was a story of in this biography of him I read of Michelson being invited to all these places in Europe to give scientific lectures at the very top places. He was absolutely at the top of his profession. And there was a dining hall where they had two groups of people. They had separated in actual separate tables. One was the old people who still believed in the luminiferous ether, and one was this, the young blood who had, this was around 1912 or something, they were all switching over and buying into relativity theory. And Michelson had his tray of food, and he looked at both tables, and he sat down with the people who still believed in the ether, right? And that was a real blow to the, to the people who believed in relativity theory. And that's totally understandable, right? I mean, that's human nature. That's a very human thing to do. And so it really shouldn't be surprising that suffuses science. I just think that's a great example of, scientists are human too. So of course they are subject to all sorts of incentive systems, social rewards, peer acceptance, as well as funding and positions, right? So I hope that addresses your question about rewards in the science system. Of course.
Yeah, I definitely appreciate that. Obviously we don't need to go super deep on it, but it's always useful just to, I've been trying to collate a series of views on people, just sort of, even if it's extemporaneous, right, talking about what they view as sort of the most, the strongest currents when it comes to people's incentive system, because obviously incentives are how we as humans operate. As far as I can tell. So where would you like to go from there?
So I wanted to talk about Kuhn a little bit, because to set up that, I think in this way of setting up this question of science versus pseudoscience, your audience or you might be misunderstanding the total dynamic. It's not just that there are people who are, trying to get the government to cover aromatherapy, right, as a treatment method, right? It's not just, or whatever. It's not just that there are people who are not doing something scientifically sound that are trying to get it qualified as being scientifically sound. But I really think this demarcation criterion, or the attempt to get one, is relevant in the other direction. A lot of people are trying to use or trying to come up with some way to keep good science from remaining in the science category. It's not just people trying to get bad stuff into the science category. They're trying to get good stuff out of the science category, right? And when you look at it that way, I'm going to give you a whole bunch of examples of that, and we can have discussions about each example or what you think. I mean, these examples I sort of came up with on my own. It's how things seem to me if you're making a political or social judgment. But I think that's the real relevance of the structure of scientific revolutions. It gave a kind of a game plan for taking science down a peg and bringing it down to the level of other human activities. And that's why Kuhn is so relevant. If you understand Kuhn and the aftermath of Kuhn, you'll start to understand why Kuhn is cited so much. It's because Kuhn helps you do that job of bringing down certain aspects of quote unquote objective science. That's how I see the relevance of Kuhn, right? It's almost like a playbook for attacking good science. Does that sound?
Yeah, no, that sounds great. So just maybe to paraphrase what it sounds like to me, there are, and this is something actually even when I was reading some work from Demarcation, he said something quite similar where it was the idea that this essentially, the moment that the sort of science was taken off the pedestal from being a purely objective phenomena and a set of inquiry to saying, well, there actually are a number of sort of social, there are many subjective, for example, underpinnings to even very good science. And that one thing that people said, aha, it's been taken down a level, like essentially the bridge is there, now we can board. And
exactly.
It's essentially just a humanities. And also another aspect is, and you've mentioned this as well, is the idea that the designation of pseudoscience is in some sense like an emotive thing. So essentially,
it's a very bad label to have attached to your position. So it's a very powerful weapon. If you can get something dismissed as pseudoscience, you're winning the argument for sure.
Yeah. So effectively it can be used, for example, to act as a blocking mechanism so that any scientific inquiry that is counter to what your own interests are can be blocked on that way. If you can get people to dismiss a new method as pseudoscience, you're in a good way. You're in a good position to essentially keep it from entering the discussion. So the floor is yours. You can go where you want.
I have to say, give my own professional philosophical position. I think Deanne had it right. It's sort of like pornography. I can't define science, but I know it when I see it. I do think, I'm doubtful that there is a set of necessary and sufficient conditions for something's being science. But that doesn't mean we should give up on the distinction. I think there are a lot of things in life where you can't articulate necessary and sufficient conditions. What is art? What is religion? So science might be like that. But that doesn't mean that there aren't clear cases of nonsense and clear cases of science. When I was talking about people who I think are running the Kuhnian playbook, I really got thinking about this I started graduate school at Syracuse University 32 years ago in the fall. And one of the first conversations I had was with somebody outside of the department. It was social sciences person I won't name, but they had done some work on something that I had also written a little bit about on philanthropy. So I met them in their office and I asked them what they were doing next. And the person said, well, I'm doing a study that's going to show that Reagan's policies increased homelessness. And I said, oh, you mean you're going to do a study to see whether Reagan's policies increased homelessness? And he said, no, I'm going to do a study to show that Reagan's policies increased homelessness. And being, the naive 22-year-old that I was, I said, well, don't you have to do the study first to see whether the evidence supports your conclusion? And he said, well, as Thomas Kuhn showed us, there is no value-neutral science. And I got a glimpse there of sort of the uses to which Kuhn could be put, right? It really gave license to admit, so I'm laying my agenda on the table, or I'm laying my preferences on the table, and that's okay. So we're going to validate as scientific approaches that, or to particular problems, or just larger approaches that I would say that that's not the right way to go. You should do the study first and see if the data support it, rather than going into it with a belief about what you want the conclusion to be. But that's just, I'm just, I guess, an old philosophy fuddy-duddy, because an awful lot of people in the humanities and in social science, they were relieved. They were happy to hear Kuhn's news, because I think this is where I say I'm giving my, I may be stirring the pot here, but giving my own take on things, is that it gave them license to do things that they wanted to do. It also took science down a peg. And if you're familiar with universities, boy, there's salary differences. Scientists get the grant money that people in the humanities don't. They can get higher salaries. Their tenure and promotion criteria are different. The prestige they hold is different. Science departments don't get targeted for elimination by governing boards or state legislatures the way perhaps that humanities and social sciences do. So, there is a lot of interest on the university campus by constituencies for bringing science back to the fold, right? If you can bring back physics or chemistry to be just like or very similar to history or psychology or what have you, that is a win for a lot of academics. I don't know if you wanted to ask me more about that, but that was sort of the first thing that came to my mind.
Actually, my only comment from that story was just saying, that's really unfortunate, because that the honest way to do that is you're meant to corrupt the experimental design and metrics that then will inevitably lead to your results.
You're not supposed to announce it, right? You're just supposed to build it into the way you measure things.
Yeah, which takes some work. Right. You have to earn. You have to earn.
But I kind of admire somebody for just coming right out and saying it. Of course, maybe he said it to me because I was just a kid. But I just, I think, what they say, hypocrisy is the tribute that vice pays to virtue, right? Maybe we can't eliminate our own biases, but that doesn't mean we should proudly announce our biases and wear them on our sleeves. We should try, make the best efforts we can to keep those out of the equation. Now, you might just say, well, there is no such thing as being unbiased. And now you're into a really philosophical discussion. And then I'm back to saying, well, I can't define unbiased, but I know biased when I see it, right? So.
Yeah. And just, I think one helpful analogy, there's something called either, I only came across this recently, it's called the fallacy of the pile or the fallacy of the beard. And the idea is, it's the same fallacy, but it's the idea that when someone has a pile of sand, you can take away one grain at a time, right, and eventually you'll go from having a pile, right, to not having a, right, pile. And the issue is, even though there's no one defined point at, right, which you have gone from not a pile to a pile, that doesn't mean that the difference doesn't exist. And so it's one that actually Deborah Mayo has brought up before, right, and I found it extremely helpful for trying to sort of make a better sense of some of these subjective, right, measurements, where it's like, yes, there's a subjectivity, but there's definitely a distinction in the extremes.
Right.
And the fact that there's a fuzziness in the middle doesn't mean that the distinction, right, isn't real.
Yeah, there's actually, this is a very, very ancient puzzle. It's called the Sorites paradox. So if you just want to look up that word, Sorites paradox, there's a gigantic literature on this in philosophy. It goes back to ancient Greece, So just more cases of, I think, people running Kuhn's playbook. And again, these aren't in any particular order. They're just things that came to my mind. I would say global warming denialists, right? It's not just that, especially with something like that, where there is so much science on of climate change. It's not just enough to elevate a researcher here or there and say, well, they've got contrary evidence, so it's a wash, and we don't have any reason to act now. You also have to discredit the conclusions being drawn by mainstream climate science, and that's where you get some running of the Kuhn playbook, I would say, right? And we all know the claims, right? Climate scientists are politicized. They have an agenda. That's where all the money is going. They're just trying to achieve political popularity. I printed out, and it's such a spectacle. This person. Have you heard of Senator James Inhofe of Oklahoma?
I'll admit I have not memorized the names of our 100 senators.
But he's Inhofe, and he is the leading elected official in the United States. I would say denying the existence of climate change and the science behind it or the relevance of it. But he gave a speech on the Senate floor, and I just marked off a couple passages. He said, other agencies, he's talking about the Obama administration, this is from several years ago, other agencies have spared no taxpayer expense supporting outcome-driven, and then he says science, right? In an attempt to bolster their claims. He said that there was a whistleblower at the National Oceanic and Atmospheric Administration saying that data were manipulated. And again, just running down the whole enterprise as being dominated by partisans who have an agenda, right? It's not that he is saying it's bad science. It doesn't even rise to the level, in his view, of having been conducted properly. It's agenda driven down to the very bottom. Okay, and that's a powerful move. People believe that they don't need to listen to anything that is coming out from whatever study it is you're hearing. It's all just people with an agenda.
Yeah. So basically, it's being presented as an alternative to, for example, directly critiquing some aspect of the data or some misconception of the actual climatological or geological mechanisms.
And he does that. Inhofe and others do that too. So they say, if you say, "Hey, look, the data collection is off because the places where the temperatures are being measured are in cities, and these are heat sinks, and so it's not really representative of the climate of the planet as a whole." Well, that may be false, but at least that's a scientific objection. But this is I'm teaching logic right now. We cover these so-called logical fallacies, right? Common mistakes in reasoning that actually are effective because people fall for them so often, and it's just a case of ad hominem, right? You're attacking this or poisoning the well, you might say, just attacking the person, attacking the source, and discrediting the very source, right? So that everything subsequently based on that source is also discredited.
Are people attacking the healing crystal folks the same way? Are healing crystal folks getting their same?
Are the healing crystal? The question is, are the healing crystal folks attacking mainstream scientists that way? And I would say yes. I mean, I had skipping ahead to this one, but I didn't even list it. Anti-vaxxers, right? I haven't read all the anti-vaxxer literature because I haven't read any of it. I got better things to do with my time, right? But because the game plan, they're going to say it's doctors trying to create patients or drug companies trying to make a buck and create a need in people that they don't really have. They're using the shroud or the cloak of science to actually create a market for their own products. I mean, that kind of argument is made across the board when it comes to medical products, right? You said the healing crystals people. Let's do something a little more, a little less extreme, but how about acupuncture and chiropractic as things that can get reimbursed by health plans? In fact, I was surprised when I did go to a chiropractor once that it was covered. You can get it covered by a health plan. They're going to say that Western medicine is rigged against traditional medicine or alternative medicine so that they can continue getting the money, right? They say Western scientific medicine deliberately ignores non-Western or non-traditional medicines as a power move, and they aren't really looking at it fairly because they're protecting their own turf, right? That to me is an instance of trying to pull science back into the non-science realm, right? That at least that's how it seems to me.
Yeah, I guess just to obviously just to push back on a thing or two, because one, obviously we're just here to have a conversation, and one of the things I've really liked about philosophers is that they don't mind people going. So there's a few things I think that are interesting here. One, and this is one that's it's basically, given that I tend to hold more like traditional mainstream views that people with PhDs in scientific realms tend to hold, there is one issue here, which is that basically, well, there's many issues, but one that I find particularly interesting is that effectively, when you put the burden of a large sort of learning burden on people, for example, with PhDs in science, who effectively have a high opportunity cost of their time. And so the idea is saying like, okay, I, for example, also have not read the anti-vaccination literature. I'm familiar with certain little bits here and there, but I wouldn't say that effectively I've given it any fair chance whatsoever. And there's a perfectly good reason for that beyond just, that doesn't just mean I'm being curious. It's the fact that there's an opportunity cost of my time. There's a value in somebody who can basically automate algorithms to monitor patients 24/7. And if I'm giving up my time from that endeavor to do something else, then effectively, it would be, I would experience a loss from doing that. At the same time, it means that I also have not actually rigorously in any way, shape, or form actually evaluated it, and I'm leaving that to somebody else. And so I guess the bit that I'm not quite satisfied that my own approach is correct. At the same time, I've seen in many cases, for example, where if someone in academics or someone trying to push an idea, right or wrong, if you provide a giant tome of knowledge, like an 800-page book saying, I'm correct, you just have to read my 800-page book to do that. Obviously, there's a huge opportunity cost there. And it seems to me that it's a little bit like it's creating a barrier to entry, a barrier to critique in itself. And the idea that essentially you're making this insurmountable fence.
I completely understand what you're saying. Can finish, but I completely agree with that. I don't disagree with that at all.
Yeah. And I guess similarly, for things like acupuncture or chiropractic, again, I haven't done those things myself. At the same time, I guess it's twofold. And I guess I'd throw homeopathy in there as well, because which one is like, that one really messes with my brain, because one, I don't even entirely understand what it means. I think that the definition, there's a formal definition, but I think it also other things get glommed on top of that. But for things like that, and I'll maybe stick with chiropractic and acupuncture, that, as someone who has looked at clinical trial design as part of my career, there are bits where you could actually reasonably say, for example, that traditional clinical trial design might not actually cover some of the clinical endpoints, given that you essentially need a magnitude of efficacy. You need things like that to actually determine by a clinical trial where these things are useful, and especially for things like chiropractic, and I assume acupuncture is the same thing with handling pain, where pain studies are notoriously difficult. They're even difficult for pharmaceutical companies. You can just numb people with narcotics, and it's still, even with those scenarios, it's hard. So it's one of those things where, while I don't practice it myself, I find it much harder. I'm a bit more, I guess I can say, I'm a bit more ambiguous or agnostic about those, because it seems like there's
I feel like I've been misunderstood here. I'm not critiquing either chiropractic or acupuncture. In fact, I've used chiropractors before. I stopped because of probably it isn't good for my neck, and they like to crack your neck. But I used to find great value in it, and I'm not saying that there is no knowledge beyond what science provides. That was what you talked about in the last discussion about scientism. I'm not trying to say that. What I'm saying, what the general point I'm trying to get across, right, is this: if you are aware of the history of the science pseudoscience debate and the attempt to demarcate science from non-science, if you went back 60 years, you could almost predict how various political debates would unfold, right? I'm just commenting on the status of the political debates. It could actually be true, right, that Western medicine or scientific medicine misses very important things. I think that there's all sorts of stuff to criticize about it, but to say that it's a rigged game, or to give motives for why they're doing it as your explanation for why chiropractic isn't, for example, isn't widely endorsed by, I don't know, osteopaths or whoever. I just don't think it's just a logical fallacy to attack the motives of the people who disagree with you, right? It should be trying to find some common ground. Kuhn, however, and I don't know that he meant this, but he gave a method for just, here's how you chop down science. You just follow this checklist. Again, I don't know if that's clicking with you or not, but it's,
yeah, no, it definitely is. One, obviously, I think that, for example, obviously I'd be sympathetic to both sides. One, where people are saying like, I'm agnostic on the efficacy of this because it's difficult to measure endpoints. Right. And therefore, given that it is not aligned with the way that we have done other very productive scientific endeavors, that I choose to be agnostic, or that my end results on this is agnostic. And another person might just say, you know what, given the supply cost versus benefit on this, it may well work out. And I think that as far as the Kuhnian distinction, it's hard to ignore the fact that he did describe a legitimate phenomena, like a legitimate social mechanism in the scientific endeavor.
He partially, I think he overinterpreted what he described. I mean,
did he not?
This is sort of an aside here, but he had this idea of incommensurability, that people who were in different, had adopted or were working within different paradigms, literally were living in different worlds. They had different, this idea of a worldview. They aren't even communicating with one another on a level, it can't be translated. So, for example, Newtonian science being one paradigm, Newtonian physics being one paradigm, Aristotelian physics, Aristotle's physics, right, being another one, where for Newton, the thing that needs to be explained is not why something is moving, but why something is accelerating. That's such a tremendous difference in your starting point for doing physics that you might think there isn't any common ground to have to look at the phenomena the same way. That's how Kuhn looked at it. But I just think that's, when I say he overinterpreted that phenomenon, clearly there are people who can hold both views in their mind. So if you go to somebody like Einstein, he did know Newton's theory, right? He knew it well enough, and lived within it to come up with an alternative to it. He also understood his own theory. He was the inventor of it. So there is somebody who lived in both worlds, right? He found these theories commensurable, but Kuhn took these phenomena and used them to push a kind of conceptual relativism, right? That there is no truth beyond the conceptual scheme used to address it. That I just don't think was, that conceptual relativism may be correct, but his argument didn't establish it, I thought.
Yeah. And you would know the answer to this better than I, so I'm just going to ask. I had read from some bits where essentially there was the initial sort of Kuhnian thesis, and that effectively in the blowback. So essentially, he said, science is this essentially social phenomenon. As you said, that there are essentially different value-laden paradigms that essentially mean that people are more or less talking across each other, living in two fundamentally different sort of paradigms. And that in reaction to that blowback, Kuhn sort of refocused and revised his arguments in some way. Are you familiar with that?
Yeah, well, I don't think when he wrote it, anyone could anticipate when you're a philosopher of science, right, that you're going to write a book that is suddenly cited absolutely everywhere as this incredibly influential thing. And he did see the uses to which it was being put, and he tried to dial it down a lot in some subsequent papers, which I don't have at hand. I can't remember, but he did try to dial it back, but the cat was out of the bag, once he wrote the book.
Yeah, that is really helpful. And actually, on that note, we won't go into it here just because obviously I'd like to explore more of the ideas that you have brought to the table, because you have obviously prepared us a very nice buffet of examples.
Right.
But yeah, definitely at some point in the future, I remember jotting down some of the more interesting examples of Kuhn's idea that basically people were working from different paradigms depending on the values that underlaid it, and just knocking out some of those examples. So for the listeners who are interested in that, we'll do an episode on that and just really try to dig into that idea later. But where would you actually go from there?
Intelligent design theory is another one where I see this dynamic. So I don't know if you talked about creation science. There's a long history here. There was scientific creationism in response to the Scopes trial, right? And the idea is the idea of the creationists is we were going to have something taught alongside biology, evolutionary biology, but as an alternative to it. And that got knocked down in the late 1970s in a court case. I think it was McLean versus Arkansas, but which, by the way, is a very interesting court case, as is this court case about intelligent design theory, a court case called Kitzmiller versus Dover out of Pennsylvania, which is that it's not just, I'd like to have an idea of objective science. The law itself, I talked with one person in particular, a person who gave testimony, a philosopher of science, in that 1979 creationism trial, a man named Michael Roos. And he said he was testifying, against creation science, and he was told by the lawyers, you can't argue that it's bad science. You can't argue that it's false. You have to argue. The law demands that we show that it is not science, right? So the law was written in such a way that there being a distinction between science and non-science was presupposed, and they had to prove it was not science. So that's just coming from the law. And the same thing was the case in the Kitzmiller versus Dover story. So this thing, intelligent design theory, was developed in the 1990s. Many think as a response to the loss in the Arkansas and creation trial and other losses on teaching scientific creationism. And they were pointing to phenomena in biology that they said couldn't be explained by evolutionary theory. They talked about, I don't know if you've heard of irreducible complexity. That was supposedly something that couldn't possibly be explained naturalistically. The very origin of life supposedly couldn't be naturalistically explained. And the intelligent design literature was going to be, or it was proposed that it be included in high school science curricula in this, I think it was this county in Pennsylvania. And there was a lawsuit about that, where again, the court was asked to judge on whether this was or was not science. Okay. And you've actually got a opinion by the judge there, federal judge John Jones. One section of the opinion was why intelligent design theory is not science. Interesting reading if you're interested in criteria of what is or is not science. But the intelligent design theorists, they weren't just trying to get what they were doing to count as science, but they were also just as much concerned to say that contemporary evolutionary biology was in fact on the way out. There's a book going back, I think, 40 years, Evolution, a Theory in Crisis. It just maps out exactly the Kuhnian game plan. He said that there are anomalies in modern evolutionary biology that just are not and cannot be solved by the evolutionary approach. But the community of scientists is papering it over because they want to retain control. There's a power structure in the field that suppresses exploration of these anomalies because then the whole field falls apart. That's the kind of thing they're saying. I'm not saying that Michael Denton made those allegations in particular about evolutionary theory, but that's in the air with intelligent design theorists. Is that, yeah, from their perspective, they are the upstarts, right? They are the new paradigm, and they are trying to cut through all the desperate last gasp measures of the evolutionists to hold on to their social and political prestige.
Cool. Just if you wouldn't mind, just a quick distinction, because I think that this is a useful categorization, or alternatively, it's a not useful categorization that's useful to think about. The idea of we have science and we have not science. So effectively, there are some undoubtedly scientific things, physics,
right,
astronomy, things like that. There's also things that are simply nothing really to do with science. For example, I was going to say sailing, but I don't know. I don't really like that one. Maybe, playing kickball, for example, a kickball game. It's not really what we consider in the realm of science. And actually, I guess the Brad Montfort article on pseudoscience is now popping into my head, where it says, there's also there's bad science, where it's people, they're pursuing scientific methods and they go awry due to, for example, error or something like that, an unintentional error. And they might even arrive at the wrong result or the right result, but they essentially maybe confounded a method in the process. So within the realm of science, we have good science and bad science. We also have non-science, and that there's also pseudoscience, which is
trying to adopt all the errors of science, right? It's deliberately trying to pass as science.
Mm-hmm.
Right.
Yeah. And so effectively, even some of these arguments where people, you would say, actually they're on the correct side or in agreement with current science, like the current cutting edge of science, that when you're trying to say something like A is science and B is not science, that effectively we're running afoul of the fact that even people who rigorously care about science realize that there's gray zones in here. Is that one of the issues that you're bringing up?
Well, or? I mean, that's actually the next one I'm going to bring up. So you said, well, physics is definitely science. Well,
but theoretical physics, for example, yeah.
Well, yeah, so is string theory physics? I was going to talk about the multiverse hypothesis for a second, right? Is that science, right? Some people say it is, some people say it isn't. So I don't know if your audience might be familiar. I've heard of these terms, the anthropic principle or cosmic fine-tuning. It's the idea that the parameters in physics, as discovered by physicists and cosmologists, right, that they are exactly what they need to be for life to even be possible in the universe, right? You can, look at every element in your body besides the hydrogen, and there might be helium, I don't know, right, was produced inside of a star. So everything above helium, right, on the periodic table of elements was produced as a result of nucleosynthesis in the star. And what are the preconditions necessary for stars to form and to have nucleosynthesis in their core and then explode and send that stuff out so that later it gets picked up into a planet. All the physics necessary for that seems to be very, very sensitive to changes in the values of things like the force strengths. So that if those were just a little bit different, you wouldn't have life anywhere in the universe. Well, that's fine-tuning. Okay, that's the fine-tuning idea. And as you can imagine, some people have jumped on that as evidence for the existence of a designer of the universe, somebody who picked those numbers to be just what they are. And there's this thing, the multiverse hypothesis, which is thought by some to explain the fine-tuning we observe, but without bringing a supernatural being into the equation. And that is that there are all sorts of other universes, bubble universes or what have you. And the values of these parameters are variable in these different bubble universes. But if you have enough of them, one of the universes is going to have the right characteristics. And of course, we wouldn't be observing a universe if it didn't have the right characteristics. So really, that's the explanation for fine-tuning. The question isn't why is the universe fine-tuned? The right question on this view is, why are we observing a universe that's fine-tuned? And the answer is, well, because we couldn't observe a universe that isn't fine-tuned, but there is likely to be a fine-tuned universe, given that there are so many other universes. I ran through that pretty quickly, but I don't know if you've heard of that line of thought before or not.
I think actually that one is one of the ones that always comes to mind. That I think that statisticians and data scientists would really glom onto, because effectively it's conditional reasoning.
That's right. It's all, and I cover this in my articles and books. It's all Bayesian reasoning, But going back to the relationship of this to Kuhn, I just noticed that a lot of the proponents of the design argument, of the fine-tuning argument, were attacking the motives of the scientists who put forth the multiverse hypothesis. So I've got two quotations that I pulled out from an article of mine. One is from a Cardinal, Christoph Schönborn, who was basically Pope Benedict's right-hand man on scientific matters, from what I understood. He said, quote, "Now at the beginning of the 21st century, faced with scientific claims like neo-Darwinism and the multiverse hypothesis and cosmology," and then this is the part I want to emphasize, he says, "which were invented to avoid the overwhelming evidence for purpose and design found in modern science, right? The Catholic Church, puts forward so-and-so." He's saying these were invented, right? The multiverse hypothesis was just cooked up to give atheists an alternative, right, to having to believe in God. Can't think of a more, striking example of accusing scientists of bias, right?
It's nice to have options.
They've just got overwhelming atheistic bias, and that explains why they're even looking at the theories they look at. And I've got another quotation from a guy, William Lane Craig, saying the same sort of thing, right? They just assert it to avoid the truth that's right in front of them. Yeah, sorry, you were going to say.
Oh, yeah. Oh, no, I was just going to say, well, it's always nice to have options. We have Hulu, we have Netflix, right. We have multiverse theory. We just got to have those options.
Right. I mean, it's just, so I got so annoyed by hearing this claim made over and over again, and which I thought was just an unsubstantiated claim. It could have been true. I mean, maybe, I'm not a mind reader, that I actually did a survey of cosmologists. I drew up a list by looking at physics departments across the English-speaking world and in even the non-English-speaking world, because there's so many English language speakers there. And I got 126 cosmologists to respond to my survey. I ended up publishing the results. But one of the questions I asked is, I didn't want to ask them why they did or didn't believe in the multiverse hypothesis, but I just said, what do you think explains the interest in the multiverse hypothesis, within the physics community? And I gave them five options ranging from not at all because of the scientific merits of the idea, and entirely in order to avoid the consequences of the apparent fine-tuning of the universe, all the way down to mostly to avoid it, 50-50, mostly because of the science and entirely because of the science. And I don't know if that setup makes sense of that 5-point scale there. One person out of 100 respondents said it was totally not at all because of science and purely to explain away fine-tuning. And then the rest were sort of it was about even in each category. An awful lot of people said the multiverse hypothesis is entirely motivated by science. It seems to be fall out from quantum cosmology, for example. I just think that this claim, which is again an extremely strong claim, that there's profound corruption in modern physics and cosmology when it comes to the fine-tuning argument. I think that's just unsubstantiated, but it's just people running, the discrediting playbook that, again, I said, I don't think Kuhn intended it for it to be that way, but, it's just running that playbook. I don't know if you had any comment about that or thought about that.
Yeah, I know. I mean, I think that is interesting. I was interested to hear when you said, I did a survey on this. I was like, I wonder if it's going to be like just like one outlier and then a few in the middle and then sort of more on the higher end. And essentially, yeah, it sounds like it was.
Again, there were some people who were skeptical about the interest in the multiverse hypothesis. Mm-hmm. I asked that question in the survey too. Do you think it's scientific, the hypothesis? Is it testable? Because there are people who say that aspect of physics, it's not science, it's pseudoscience, it's mysticism. And you'll get that criticism from fellow physicists, right? You'll get that about multiverse theories. You'll get that about string theory. I don't know if there's a great book title, Not Even Wrong, right? And that's about string theory. It doesn't even rise to the level of being false, is the claim of the author. They're hashing it out there. But if you actually look at what the physicists say, I think enough of them regard it as scientific to not to reject this criticism of its simply being motivated reasoning, right? Yeah.
I guess for me, when I looked at, because I always thought that was one of the interesting things of the non-testability of something as a useful distinction of whether or not it's scientific.
Right.
And one of the main distinctions that I thought was, one of the things that I think that is sort of a bit fundamental to particularly scientific endeavors, as opposed to, for example, logical endeavors or mathematical inquiry, is that there is typically some inductive step along the way. And I find that to be a very useful thing to just say, like we have math, which is obviously has a lot of deductive, it's basically knowledge built on deductive guarantees. Right. And then science, the reason that we think it's special is, it has these areas for flaw due to inductive problems, but at the same time, it gets it really right and still moves forward very usefully. And so the theoretical physics one was always one that stuck out because basically it's not quite testable. Some of it is based on induction, but a lot of it's essentially logical deduction from a set of principles.
Yeah, but it also, you got to think about a time scale, right? I mean, usually or often in physics, theory comes first, and then the ability to test that theory comes later, right? And I can't. Sir Arthur Eddington, right? It took a while to find the conditions to do a test of Einstein's relativity theory. And wasn't this the experiment where Eddington went to, I believe, he watched an eclipse, I believe, at the tip of South America, where he could detect, that the star, the light from the star that was behind the sun was being bent by the sun. Right.
Yeah. So they actually formed an expedition. I think they also had a follow-up expedition at some point. Right. But they I thought it was like Madagascar. I thought it was like either
it was some South very Africa. Remote place, right? But
going around the tip.
At the time, you can't always just come up with a testable consequence of a theory on the spot. And you go back to black holes, which were a theoretical consequence of general relativity. And, but you might think, well, by their nature, they don't emit any light. How are we going to detect them? Well, that came later, right? So I wouldn't want to, this issue of what counts as a testable theory is itself, that's a very tricky issue. Are you talking about testable right now? Are you talking about testable in the future with better experimental equipment or maybe a better perspective? like the Hubble Space Telescope completely revolutionized astronomy because you had a telescope that was not bound by the Earth's atmosphere, right? Well, that was, you could have guessed at what the experiments would have been if you had a tool like that. You could have guessed at those in the 1940s or 1950s, but it took time to get to that point to be able to actually do those experiments. I bring that up in the case of the multiverse hypothesis because there are quite a number of physicists I saw from my survey who do think there are testable consequences of the hypothesis, either testable right now, or we could develop tests in the future. You could perhaps see some signature or trace of the collision of our universe with some other universe in a bubble or in a bubble matrix, okay, on that view of the multiverse. And that could show up in the cosmic background radiation, right? So, you got to be careful declaring something to be untestable. Scientists are really clever. A lot of times they'll rise to the challenge and come up with a test.
Yeah, I'm definitely in favor of the idea that instrumentation will increase our ability to basically increase the space of hypotheses. Even in the very basic example where I do my professional work, the instrumentation, medical devices, wearables, and things like that is bringing about new hypotheses on what's actually going on in the human body that we haven't detected yet. And, obviously we have almost 10 billion human beings on which to observe. They're constantly producing vital signs if they're alive and things like that. And so even for this, what should be hopefully very well-known thing, we aren't the bottom of the ocean. We aren't the inside of a black hole. There's still actually hypotheses that are being, that are now possible due just to changes in instrumentation. And it's funny that you brought up the black hole example, because one of the examples that I thought of that might be an untestable hypothesis, for example, when people are hypothesizing what's inside a black hole, or the contents around those, where observing a black hole seems much easier than essentially observing and retrieving measurements from it of a certain nature. So some of those seemed less possible, but at the same time, what do you count as observation, right? I mean, you've got a person with eyes and ears and so forth looking at an instrument with the meaning of the results of that measurement are filtered through a tremendous amount of theory, right? I mean, look at the science about exoplanets, planets orbiting other stars, right? There's a lot of theoretical presuppositions behind that, theoretical presuppositions which are very, very, very well grounded, right? But nonetheless, it's not like you're just walking up to a planet around another star and just looking right at it. You've got scientists interpreting signals they're getting from all sorts of different kinds of telescopes. It's not even necessarily in the visible light spectrum that they're getting this information. So this idea that scientists just sit down and observe, correct. That's, and Kuhn was correct about that. Observation itself is laden with theories, right? You can't just, open up your eyes as an infant and you are doing observation. It's not like that. Yeah, I'm personally, I'm very much in favor of the value of deductive reasoning in science, and the idea that, besides just empirical evidence, we can make incredible leaps via deductive science. And there's nothing to say that effectively someone might be able to essentially deduce correctly the nature of some of these untestable things. And so effectively, we might know the answer without having ever tested it. It just, we'll never have gotten that empirical. It's similar to, for example, a series as things converge to infinity. It's not like we're ever testing what it does at infinity, because infinity isn't a number. But at the same time, we do know what it does. And so I think that we aren't limited. In fact, deduction is a very great way to expand our capability beyond that. I know that we're running low on your time. Yeah. Did you want to do one final example, or should we just?
I'm done with examples. I guess I don't want people leaving here thinking, Manson is the one to tell you what is and what isn't science. Because I mean, that's incredibly. I don't know that anyone can answer that, but I do want to call foul on people taking advantage of that ambiguity to really attack stuff that's valuable. Unfortunately, I think it's something that happens across the political spectrum. People from all sides can do it. Now, I was having this discussion with my friend who's a chemistry professor here and actually ran for Congress as a science candidate, right? He is a chemistry professor and he ran for Congress in North Mississippi. Didn't win, but I talked with him about his campaign all the time. And it's hard to say who's in favor, if there's a partisan angle to anti-science attitudes in certain respects or not. So are people who are anti-vaxxers, they tend to be more Republican? Do they tend to be more Democrat? I'd be interested to see, I don't know if there's polling data, the people who say they don't want to take the coronavirus vaccine. How strongly partisan is that? I'm sure there's going to be some partisan divide, but how strongly partisan is it? I don't know, but my sense is reluctance to embrace science or a desire to take down what is perceived as established science is all over the place, right? It's just a common tactic, unfortunately.
Yeah, the anti-vaccination, particularly, I guess, when I think of anti-vaxxer, I think of the autism vaccination correlation. And obviously 2020 brought up the sort of a new clade of anti-vaccination beliefs, including some people from the scientific community who were simply, it wasn't anti-vaccination as opposed to simply agnostic towards certain types of vaccination that had not been sufficiently in their mind tested. But yeah, I guess the anti-vaccination belief is, I think, sort of interesting because as far as I can tell, I can never get a read on it, whether actually it mapped to one belief or another, because there's obviously famous celebrities on one hand who have clear leanings on the left, who articulate these views. And there's also people, that are traditionally on the right who are skeptical of these things. And so that one I think is particularly interesting because effectively it bounces back and forth. Essentially, it's one set gets all. Yeah. So I think that one's interesting. It's a real haymaker in our bipartisan viewpoint. But yeah, no, I really appreciate you leading this discussion.
Hey, I think you do a great job as an interviewer, and it was a pleasure talking with you. And I hope your audience gets something out of the discussion. Anybody can look me up and email me if they have a question, I guess. I don't know. I might regret that if I become go viral or something. I hope I didn't say anything that goes viral.
Actually, as someone who has offered to just answer any statistician's questions, I can tell you, you will get you might run the risk of getting quite a few questions, but they're all good, useful questions. And
that's fine. I've done a few podcasts, and it's just part of the job to get out of the classroom, to get out of the office typing stuff, and to kind of bring it out to the public in some way. So hopefully, this is a small gesture in that direction.
Cool. And I guess the only thing left undone is the healing crystals. We never got around to the healing crystals.
I don't,
we'll have to save it for another day.
I'm not gonna lose any sleep over not giving a fair shake to the healing crystals.
That is where you and I diverge, sir.
Yeah. All right, man.
Great. Well, thanks so much for your time.
Hey,
I appreciate it.
Thanks so much. Good talking with you. Bye-bye.
Bye. Hey guys, it's Glen. Thanks for your time today. I hope you liked today's episode. If you did, please consider smashing that like button. It's the single, simplest, fastest way to make sure that YouTube shows this video to more people. If you really want to go crazy, consider subscribing or going to our website and joining the mail list. If you want to go totally crazy beyond that, forward this to a friend or colleague who you think might enjoy this too. We're a small channel and every bit helps. Our next episode will be coming out next week, so in the meantime, feel free to look around the channel and see other videos that might be of interest. As a quick disclaimer, the views expressed in the show do not represent anything other than the people saying those words, views, etc. like that. It doesn't mean anything about their employers or their employers' views or some thing about their employers or their neighbor's cat or anyone else not saying the words. And in fact, given that people tend to change their views when they're thoughtful enough, it might not even represent the views of the speaker by the time you're hearing the episode. So definitely come back and see if they've changed their views at a later date. They also don't represent the views of our sponsors. Thank you to our sponsors. You can check them out on our website.